Welcome to The Explainer. Today, we're going to pull back the curtain on the secret that makes the entire internet feel fast. And it all comes down to this really clever, intentional lie called system caching. Without it, the webs you and I know it would just grind to a halt.
So let's start with a puzzle, right? This is something that absolutely haunted early software engineers. It was this universal pain point, so bad that it honestly threatened to kill the web before it even got started.
Okay, so the core problem here, it wasn't just about things being slow. It was about what we call the source of truth in any system. You know, that one single place that has the correct, definitive answer for everything. And getting to that truth, man, it was agonizingly slow and super expensive.
Here's a great way to think about it. Imagine a restaurant, and in this restaurant, every single order, even for the same super popular dish, has to be cooked from scratch by one single overwhelmed chef. What happens? The kitchen gets totally swamped. Orders just pile up, and the whole restaurant grinds to a halt. Well, that's exactly what early computer systems were doing.
And look, this wasn't just some minor glitch. This was a huge deal. As systems got more popular and started to scale, they would literally collapse under the weight of their own success. The very traffic they wanted, the thing that made them successful, became the thing that brought them down.
So, okay, how did they even try to fix this mess? Well, before they landed on the brilliant solution we're talking about today, engineers tried all the obvious stuff. But as you're about to see, every single attempt just created new and sometimes way worse problems.
All right, attempt number 1. The most logical first step, right? Just throw more power at the source of truth itself. If the kitchen is slow, just get a bigger, better oven. Simple.
But yeah, they learned a pretty harsh lesson, and they learned it fast. You simply cannot outrun exponential traffic growth with just linear hardware improvements. It was a race they were always going to lose.
Okay, so attempt 2. If one database is too slow, why not just make a bunch of copies and spread the load out? You know, if one chef is overwhelmed, just hire more chefs and open up more kitchens. It sounds pretty smart, doesn't it?
Well, this created a whole new kind of nightmare: inconsistency. All of a sudden, different users were seeing different versions of the truth at the same time. Just imagine checking your bank balance and seeing two totally different amounts on two different screens. It was pure chaos.
So that brings us to the final, kind of desperate attempt. The idea was to let every single part of the system just remember its own answers. Think about it like every waiter in a restaurant trying to memorize the entire menu, plus all the daily specials, all by themselves in their own head.
Yeah, this led to even more chaos. A server would restart and boom, total amnesia. It forgot everything. A user could get one answer, hit refresh, get routed to a different server, and get a completely different answer. And this is where engineers learned a really crucial lesson the hard way.
And this is the key insight right here. A disorganized, totally unreliable memory is actually worse than having no memory at all. It just shatters user trust and makes trying to fix problems an absolute nightmare.
So out of the ashes of all these failures, a truly revolutionary idea started to emerge. And it was all based on a simple but incredibly powerful observation that would change everything. The idea was this: what if, instead of hammering that slow source of truth every single time for the same question, we just remembered the answer for a little while? Not forever and not for everything, but just long enough to avoid doing all that repetitive, wasteful work over and over again.
And that right there is the essence of caching. It's not a replacement for the truth. It's a shield. It's this fast, temporary memory that sits between our application and that slow, expensive source of truth, basically protecting it from getting completely overwhelmed.
But, and this is a big but, this solution is not a free lunch. Not at all. It introduces a really fundamental trade-off right at the very heart of system design. It's like this constant battle between two opposing forces.
With caching, you are making an explicit choice. You are choosing speed over absolute correctness. You're accepting that for a short period of time, the answer your system gives back might be just a little bit out of date. It is, by definition, a controlled lie.
And this is such a crucial point to understand. The whole goal of a cache isn't to be perfect. It's about survival. It's the thing that allows a system to withstand that crushing, relentless load of user traffic without just falling over.
Okay, but this whole idea creates one of the most notoriously difficult problems in all of computer science: cache invalidation. When the truth actually changes, how in the world do you tell everyone who's holding on to the old lie to just forget it?
The analogy here is perfect. It's like shouting an update across a giant city and just hoping everyone hears it at the exact same time, instantly. The real problem is consensus, getting thousands of separate parts to agree on the new truth right away. And, in a big distributed system, instantly is pretty much physically impossible.
So, the big question is, how do real-world systems actually manage this dangerous but totally essential lie at scale?
Well, they do it in layers. It's this beautiful hierarchy of controlled lies. Think of it like this. At the very top, you have the in-process cache. This is like a little sticky note on your own computer monitor. It's incredibly fast to read, right? But nobody else can see it, and if your app restarts, poof, it's gone. Okay, so one level down, you have a distributed cache, using tools you might have heard of like Redis or Memcached. This is more like a giant shared whiteboard for the entire office. Anyone can look at it, it survives if one computer restarts. But you got to get up and walk across the room to read it. That's the network hop, so it's just a little bit slower. Then even further out, you have the Edge or CDN cache. This is like taking that whiteboard and putting photocopies of it in branch offices all over the world, so it's as close to the user as possible. It's the fastest for them, but it's also the most likely to be a little bit out of date. And believe it or not, this all sits on top of the original cache, the CPU cache, which is baked right into the hardware, totally invisible to you. See the pattern? Each layer gets faster and closer to you, but at the cost of being slightly less up to the second correct.
And really, that's the ultimate takeaway here. System architecture, it's not just about building things that work. It's about making these deliberate, calculated choices. The whole art is deciding exactly how wrong you're willing to be, for which group of users, and for how long, all in the name of just keeping the entire system online and running smoothly. So, the next time you use your favorite app and it responds in a millisecond, or a web page just loads instantly, stop and ask yourself this question. What controlled lies are being told right now to make this feel so fast? Because now you know the secret. It's not magic. It's a whole series of well-managed, beautifully controlled lies.